In our previous video, we delved into modifying USB-powered computer speakers by removing the internal amplifier circuitry and integrating an external amplifier for increased wattage. However, after enhancing the power output, you might find that the bass lacks depth when you crank up the volume to a comfortable level in your everyday environment. As the saying goes, once you have a taste, you crave more. Naturally, you'd be inclined to seek out deeper bass and louder volume. But how can you achieve this within a minimalist setup and on a tight budget? One viable option is to incorporate an external 5.1 surround sound card based on the CM6206LX chipset, as discussed in a previous video, link in the description. However, this approach has a significant limitation: it only works with computer setups. It's not compatible with smartphones or other audio devices. Moreover, adding an external sound card for extended bass response may not align with the simplicity you're aiming for, especially when it necessitates additional components like a Class D amplifier, a power block, and the subwoofer itself, particularly if you lack an active subwoofer. In this video, we'll explore an alternative method for pairing a subwoofer with your modified USB speakers while maintaining simplicity and affordability. Our alternative method revolves around utilizing an integrated 2.1-channel Class D amplifier board, typically featuring a TPA3116D2 chip. This chip is engineered to deliver clean analog power of up to 50 watts per channel when paired with a well-crafted power supply. As a Class D amplifier, it boasts high efficiency and operates without demanding excessive power even at peak output levels. To showcase the simplicity and affordability of this approach, I'll construct such a system using scrap materials and salvaged parts from various old systems I've owned. The subwoofer itself is a product of repurposing parts from my miscellaneous collection, the origins of which even I'm unsure about. The enclosure I'm using is a repurposed box from an old RCA speaker, originally equipped with two 3.5-inch woofers and constructed from 3/4-inch thick MDF board. I recycled a scrap MDF board from another old speaker, cutting it to size to serve as a baffle board for the front of the enclosure. Additionally, I found a 5.25-inch driver unit with a rubber surround, suitable for subwoofer usage due to its capability for long excursions. As I plan to position the subwoofer near the main speakers and away from walls, I opted to add a port to the rear panel of the enclosure. No internal circuits are involved, as I intend to power the subwoofer using an external amplifier with an integrated low-pass filter. The 2.1-channel amplifier board that I'm using comprises two TPA3116D2 stereo chips. One chip handles the left and right channels in the lower mid to high frequency ranges, while the other combines its two channels to generate a total of 100 watts for the bass frequencies, supplying ample power to the subwoofer. These boards are readily available for around $20 to $30 on platforms like Amazon and encompass the necessary functions of multiple components typically required for similar setups. The amplifier board includes a frequency division circuit, which performs the division around 150 Hz. Below this frequency, the signals from the left and right channels are combined and redirected to the single subwoofer. While this crossover frequency may not be optimal considering human ears can perceive sound directionality above 80 Hz, it serves as a practical solution when connecting the amplifier board to smaller main speakers that may struggle to efficiently reproduce frequencies below 200 Hz, common for USB-powered compact speakers. With bass redirection set around 150 Hz, the integrated 2.1-channel Class D amplifier board proves highly effective for constructing a compact system utilizing 2 to 3-inch full-range drivers alongside a compact subwoofer lacking a built-in amplifier. The cost savings are significant. Eliminating the need for an external USB 5.1 sound card and a separate amplifier streamlines the system considerably. This integrated board combines the frequency division circuit with the main stereo and subwoofer channels on a single board, ensuring the entire system remains as compact as possible. Moreover, as these boards typically come without casing as an exposed bare circuit board, they can be easily installed on the back of a passive subwoofer using a few screws. This DIY setup functions akin to a regular subwoofer with a built-in amplifier. Now, equipped with the two main speakers, a passive subwoofer, and an integrated amplifier board capable of powering both main stereo channels and the subwoofer, integration becomes hassle-free. The amplifier board seamlessly installs on the back of the subwoofer, while the main left and right speakers connect directly to the 2.1 amplifier board. The subwoofer unit's cable also connects to the same board. Among the three knobs on the 2.1 amplifier board, the leftmost adjusts the volumes of the main stereo channels. The middle knob controls the subwoofer volume, while the right knob adjusts the overall volume of the main stereo and the subwoofer together. It's a straightforward setup. Unfortunately, there's no control for adjusting the crossover frequency that divides the subwoofer and the main stereo channels. However, given the low price of this 2.1 amplifier board, such limited functionality is understandable. The 2.1 amplifier board exclusively accepts analog stereo input via either the 3.5mm AUX connector or the provided 3-pin socket, both serving the same purpose but utilizing different connectors. It's safe to assume that most users will opt for the 3.5mm connector over the 3-pin socket. With the entire 2.1 system assembled, connecting a 3.5mm cable to the connector allows us to play music through the speakers, showcasing a significant improvement in bass. As the subwoofer handles frequencies below 150 Hz and removes the bass signal from the left and right channels, the smaller main speakers are spared from deep bass, mitigating potential distortions. Given that most acoustic energy resides in the bass region, this redirection substantially reduces distortion on the smaller main speakers. The impression of the sound quality improvement is remarkable. The sound gains a much broader scale, and the extended bass greatly enriches the ambience. Furthermore, the sound stage widens, and the separation between instruments and vocals becomes noticeably crisper. This enhancement could be attributed to the bass redirection, which alleviates the burden on the main speakers, allowing them to deliver mid and high notes with greater precision and solidity. However, if you're considering trying this method yourself, I advise against using the ONN model from Walmart. Despite noticeable sound improvement, the stock drivers in these speakers have limited power handling capacity, originally designed to work with the internal amplifier's output of around 1 watt at maximum. As a result, they may struggle to efficiently handle the increased power from the upgraded amplifier, leading to distortion at higher volumes. Choosing alternative USB speakers with greater power handling capabilities would be a more suitable option. Overall, this setup represents a significant upgrade over the standard 2-channel speaker configuration, which typically relies on small speakers for the left and right channels. In conclusion, the alternative method for enhancing USB stereo speakers by integrating a subwoofer through an integrated 2.1-channel Class D amplifier board presents a practical and cost-effective solution. By leveraging the TPA3116D2 chip and a frequency division circuit, this setup efficiently redirects bass frequencies below 150 Hz to the subwoofer, alleviating distortion on the smaller main speakers. Despite its simplicity and affordability, this system delivers a remarkable improvement in sound quality, with extended bass enriching the ambience and widening the soundstage. Moreover, the integration process is straightforward, requiring minimal hassle. While some limitations, such as the lack of crossover frequency adjustment, are noted, they are understandable given the board's affordability. Overall, this alternative method offers a significant enhancement over traditional 2-channel speaker setups, providing users with a more immersive audio experience without breaking the bank.